I met Stuart for the first time in 2005. He visited with Kevin Lesko Milan in one of the first meetings of CUORE, and I have to confess that I was frightened by this guy. He was the chair of the multidivisional study on neutrino physics, and he was presented to me as a very important physicist. He spoke very slow, very low voice, and he had also already shown a spirit of spirit of humor. So I never imagined he would become one of the most relevant person of our experiment of CUORE. At the time, he was not involved in CUORE, and for sure I didn't imagine this was the dawn of a very long collaboration who lasted until his last days. Among the titles presented by Paul this morning, I believe they are all appropriate to describe the collaboration with Stuart, but for sure most of you believe that arguing with Italians is the most appropriate. Actually, we argued many times, and probably we screamed also, even a few days before he passed away, unfortunately. But I believe this never spoiled the respect we have respectively, let me say. So I believe Stuart was a great experimentalist. I believe he also liked to argue. In many occasions, he wanted to argue at any cost, maybe to compel you to see the issue from a different point of view, from a different perspective, let me say. So I have to thank him for this, from this point of view. Okay, let me come now to CUORE. The mission of CUORE is, of course, double beta decay, and in particular one mode, which is the Neutrinoless mode, in which there is nothing accompanying the two electrons emitted in the decay, because this is related to new physics beyond the standard model. In this respect, this is coherent with the interest of Stuart in unconventional physics. And let me say that before the revolution of 1998, with the discoveries of oscillations, this was an unconventional, a side physics, let me say, for few people. I started in 1982, when nobody was really, or few people were really interested in neutrinos double beta decay. While after the discovery of neutrino oscillation and the measurement of the mixing angles, of course, the interest in Neutrinoless double beta decay grew, and of course also the project were growing accordingly. As I said before, in 2004, Stuart was chairing, together with Boris Kaiser, the multidivisional study on the physics of neutrino, and this was a relevant moment for us because few months before, Cuoricino was taking data, and this outcome of this study, which was promoting, let me say, the study for neutrinos double beta decay, was really important to our experiment. And in particular, this was really matching the new proposal. If we will see in a while, the total mass of CUORE is actually 200 kilograms of isotope. So this study matched completely the proposal of CUORE. And it was one of the three recommendations contained in that important paper. That was mainly the reason why we invited Stuart in Milan. Let me say that in my talk I would like to cover the history of CUORE that probably was never described anywhere. So CUORE, the idea of CUORE is to improve the structure of the previous prototype, which is Cuoricino, just to enlarge the mass by a factor of 20 and improving also the performance. This is a really big challenge because you have to build a system which is of the order of 1 ton. I didn't mention that the principle is the bolometer. I mean, this is 1 ton of 1 kilogram about bolometers, so you have to operate this detector at very low temperature, let me say 10 milli-K, and while maintaining the constraints coming from the fact of working at very low temperature, the fact of reducing noise, so being decoupled from mechanical vibrations, and of course of maintaining a low background, which is the most compelling factor in order to get a high sensitivity. If you get all of these, of course, you get an experiment which is reaching a sensitivity which at the time of the proposal was unique It is of the order of 10 to the 26 year. And it was touching, of course, on the side of the neutrino physics, the region of the inverted hierarchy. So it was a very challenging experiment. As I mentioned before, the bolometric technique let you to have a very good energy resolution and to build very large masses. So it's also a very good candidate for an experiment of this kind. On the other hand, CUORE would be the last step of a very old history, starting or dating back to the 80s, starting with very small masses until the mass of Cuoricino, and finally to the proposal of CUORE. This interested, for sure, Stuart, which in Milan had many questions, of course, technical questions. I forgot to say before that he showed always a true interest for experimental physics or experimental details, let me say. And he was really interested on the successful operation of Cuoricino. Of course, what was missing in the Cuoricino operation was that the mass was 20 times less than expected for CUORE, and the background was larger. So we needed to improve this, so we were not yet ready to have everything needed for building the big experiment. One of the merits of Cuoricino was to identify, in any case, the sources of the background, so that it was possible to start R&Ds in order to reduce them. In particular, they were given by a part coming from the Cryostat, so a new design of the Cryostat was needed in order to improve this part. And the new surprise was that the surface contamination of materials was dominating our background. So a lot of study was needed in reducing this. As mentioned before by John, actually the original plan of CUORE was really, let me say, optimistic, in the sense that we expected to be ready to take data in 2010, while we are now projecting the start of the activities next year, or at least at the end of this year, the start of 2015. But as I will describe later, many things were involved in the evolution of this project. Let me remind that the two big challenges are, on one side, the building of a very big bolometric detector in very controlled conditions from the point of view of radioactivity. So let me come to the history. We go back to 2004. At the time, moved by the success of Cuoricino, things were moving in Italy, and we invited Stuart in Milan. He came in Milan in 2005, and 2005 was a very crucial year, because after the crucial year for, let me say, for the collaboration between US and INFN. Because in 2005, another important event happened, which is the NUSAG report concerning the support to existing experiments. In particular, one of the outcome of the NUSAG report of this study was a support also to CUORE as one of the three major experiments of interest to the US. And one of the items that were of concern of this panel was that the requested budget share was not commensurate with the US involvement in the project. At the time, the involvement of US in Cuoricino was actually low. There was a small group in Berkeley led by Rick Norman, and the USC, the South Carolina group of Frank Avignon. And this was not considered adequate for a project like CUORE. In any case, this outcome, this report, of course, moved a strong reaction by the president of INFN and the enthusiasm towards CUORE. This is why 2005 is a very important moment, let me say. In 2006, there was the first internal DOE review at Berkeley after internal discussion in 2005. In our internal discussion, we finally defined the roles of the two big sections of the collaboration, the US and the Italian collaboration, which actually became on equal footing a collaboration between US and Italy. So we can consider CUORE as as a real collaboration between the two with equal rights. This was also demonstrated by the construction of an MOU and of the and of the exec board and other managing system of the experiment. Okay, in the internal review, the same question went out as for NUSAG, so we had to increase the consistency of the US group, and this came to the introduction within the collaboration of a bigger group, of the group of Stuart Friedman. The other groups joined at short the collaboration, the Wisconsin group, which was led by one of the students of Stuart, which is Carsten Eger. And the items in the responsibility of the US became actually very important and very compelling as the other ones. At the time, I discovered another capacity of Stuart. Let me say that despite his hate for bureaucracy, he was very able in managing bureaucracy, and he was able to explain to us, which we believed that bureaucracy was only a problem of the Italians, that bureaucracy exists also in the US. And we had to follow all the steps, the unavoidable steps needed for the approval, until we arrived finally, mainly thanks to Stuart, CUORE arrived at the approval of the CD2 and CD3 in 2009. This is one of the points I mentioned before when I discussed the planning. There was, of course, a mismatch between the original planning built simply by the Italians and the fact that the approval on the US came later. At a certain point, we had to manage also this and to destroy this mismatch. Of course, this happened later after the approval in the US of the experiment. Okay, this is, let me say, the last step of this political issue, which is the signature of the Memorandum of Understanding, in which the contribution of Stuart was really great, and which somehow outlines the structure of the collaboration and the rules of the collaboration. Okay, at that point we had a true collaboration which is a US-Italian collaboration with 9 groups from Italy and 6 from the USA for a total of about 110 researchers working on this experiment. Let me point out that one of the other characteristics of Stuart, in my opinion, was prudence. He was scared, let me say, of making directly the jump from Cuoricino to CUORE, and he was one of the strongest supporters of an intermediate step before going to the final detector. This was called CUOre-0, and in the following slide I tried to summarize one of the slides of Stuart proposing CUOre-0, in which he outlined the advantages of having this intermediate step before going to the final detector. One of the items, apart from testing, of course, the changes we adopted with respect to Cuoricino, was the fact that this was important also to provide new data, especially for the youngest people, in order to let youngest people to be able to analyze data and produce physics. So the structure was to build a single tower, one of the 19 towers, built exactly in the same way and operate it inside the old cryostat of Cuoricino. After a lot of suffering steps, we were able finally to start data taking in May of the past year. And so now we have an experiment which is taking data, which is CUORE-0. So CUORE-0 is installed inside the old cryostat and is taking data since March 2013, let me say. These are pictures of the different phases of the preparation of the detector, which reflect exactly the operation needed for CUORE. Results coming from Cuoricino are exciting, let me say. They show that we are very close to the design for CUORE. We got a resolution on the background which is 5.6 against a 5, an expected resolution, average resolution of 5. But let me say that this has been improved recently after a maintenance of the cryostat. So we are even more closer. Let me say we have reached. But the most relevant result we got from Cuoricino and is the fact that we measure for the first time the background in the new detector, let me say. And we discovered that we got a reduction with respect to Cuoricino of the order of a factor 6 in the region which is dominating, the region of the alpha decays, let me take, which is dominating the background. So we are now very confident that we are also reaching the goal for what concerns the background. This can be put quantitatively in this way. This is our goal, and this is the, let me say, the part or the residual part of the background which is dominating the Cuoricino background. So you see that you are a factor of about 2.5 with respect to the goal of the background of the expected for CUORE. But also here, it depends on the hypothesis on the underlying background. So it's possible that we are actually close to the final goal. Concerning instead the schedule of the experiment, we expect to collect the statistics close to reach the sensitivity of the previous Cuoricino in 1 year. So we expect this year to get a result competitive with Cuoricino. Concerning instead a quick look to the CUORE status, let me say that we are now approaching the final stage of the preparation of the experiment. So the preparation of the parts is almost completed, and we have started in 2013 the construction of the detector, and we are more than halfway in this preparation. We have 13, let me say, 12 towers which have been assembled mechanically, so they are assembled in putting together the bolometers, and 9 of them are completed with the wiring and ready to be installed. I remind to you that we have to build 19, so we have really passed the half. And the most compelling activity instead is the one of the cryogenic setup. Also here we started in 2012 the commissioning of the system, and in 2013 we went through a lot of important steps, in particular the cool down to 4K, which was successful, and we are now approaching one of the most critical activity, which is the first cool down to base temperature, which is expected in, let me say, in a couple of weeks. This is the structure of our cryostat, and this is where we expect to install the detector. One of the crucial, or the most critical, or the most challenging items is the need to insert radioactive source inside the cryostat in order to calibrate also the internal part of the detector. This is a challenging activity, which is responsibility of the US group, in particular of the Wisconsin, which now has went to Yale. So it's now a responsibility of the Yale group. And these are pictures of the installation of part of this system, of the DCS inside our cryostat. These are pictures of the cryostat. These are other pictures of the cryostat, in particular with the super insulation installed around one of the shields. This should be the 4K shield. And this is a recent picture of the whole cryostat with all the plates. I mean, the low temperature section and the 4K temperature section on the top. Concerning the detector assembly, this is also a big change with respect to the Cuoricino activity, and also here the contribution of the US and of Stuart was important, let me say. These are pictures of the installation of one of the towers, in particular of the second, in which each element is put on position inside the glove box, which is flushed with nitrogen. And this is the final instead picture of 2 completed towers, the first 2 completed towers exposed in our storage inside the clean room in Gran Sasso. To conclude, let me remember Stuart. For his involvement in CUORE, he was always present at all collaboration meetings. This is a picture during the first meeting in Milan while discussing with Ettore Fiorini. This is at one of the social dinners at our meetings, and this is taken instead at the meeting in St. Luis Obispo. And of course, since I said he attended all the meetings of the collaboration, he is present in all the pictures at every meeting until the last one in Los Angeles. Thank you very much.